Guys, did you understand the three operators?
Yeah, yes, sir.
Great, great. So now let me talk about left shift operator. So left shift operator is an alternate operator to the multiplication operator. Let us take an example. X is equal to 4. Now if I perform x into 2, and if I perform x left shift 1, అంటే ఉన్న 4 అనే దాన్ని మల్టిప్లై విత్ 2 అయితే అవుట్పుట్ ఏమొస్తుంది 8. Even if you perform the left shift one time to the bitwise level, it is also produced as an output. Can you see the output now? ఒక పని చేద్దాం, ఇంకొకటి అవుట్పుట్ తీసుకుందాం, లేకపోతే ఇంకొకటి ఫైల్ తీసుకుందాం. bitwise left shift operator. Clear? Now you see the output. Are you seeing, guys? This is an output of this. This is an output of this. Which means that during research, scientifically proved that left shift operation is lesser burden to the arithmetic logic unit to perform the operation. So wherever you are going to use that there is a application called multiplication. Why don't you use this left shift? Let's suppose now I will be multiply x into 4 is going to become a 16, and left shift twice is also going to become a 16 as an output. You see, 16. If I multiply 4 into 8, and if we left shift 3 times, will also be the same. If you perform the 16 4 times, same. Are you clear, guys? So how did you get this output? There is a point. Now let me take, yeah. So here our actual value is what? 4. 4 means 1 0 0. 1 0 0 is means what? 4 2 1 means it is the fourth value. Weightage of this one is 4 2 1. So I am performing left shift operation one time, which means this position is going to move to this, the value which is going to be shifted to the next position, which means what? The value is going to become what? This particular one is shifted to here. Yeah, 1. This 0 will be moved to in this position. 0. This 0 is going to move to this particular position, so that it's a 0. Now, this position is going to be vacant because it is already shifted. This position is going to become a vacant. Now, according to the electronical communication, whatever the position became vacant is going to be pushed with explicitly 0. Now, the weightage is, this is the 16, this is 8, 4, sorry. This is going to be a 1,
841.
this is going to be a 2, this is going to be a 4, this is going to be 8. So, I said, right, if we perform the 2 into 2 into, sorry, 4 into 4 into 2 is equal to 8, as well as the same value binary 4 is left shifted once is also 8 only. Now this value is going to become 8. If you perform the left shift 2 times, again this particular value is going to shift it to here. This value come to here. Yes or no? This 0 will come to here. This 0 will come to here. This 0 will come to here. The last position is going to become vacant. So this particular value is going to become what? It is going to push with a 0. Now 8 is going to become 16 because the position of this 1 is going to be 16. So 2 times left shift is going to become a 16. Multiplied the 4 into 4 is going to be 16 only. So the point is, whenever the computation need to perform multiplication for the given value in the form of binary weightage, then apply left shift operator rather than star. Are you clear, everyone? అందరికి అర్థమైందమ్మా అసలు లెఫ్ట్ షిఫ్ట్
Yes,
ఆపరేటర్
sir.
ఎందుకు అనేది?
Yes, sir.
Yes. So scientific reasons ఉన్నాయి వాటికి. Probably being a practitioner, being an employee, I think you are not working on that particular level. If you really work for the scientific level, you will be used why left shift operator are used most frequently instead of the multiplication operator. Computer science people get to know that. But so the next operator is that. The next operator is that right shift operator. Right shift operator used to be an alternate operator for the division operator. When a number need to get a result as division operation does. Example, y is equal to 20. If we perform the y right shift 1 and print y divided by 2, You see the result? ఒక వాల్యూని 2తో డివైడ్ చేసిన అదే రిజల్ట్ వస్తుంది. ఒక వాల్యూని రైట్ షిఫ్ట్ ఒక్కసారి చేసిన అదే రిజల్ట్ వస్తుంది. You see? Then the scientifically it is saying that, wherever you are going to perform the division operation in a binary sequential weightage manner, better you replace the division operator with a right shift operator. Scientifically, phenomena is saying to reduce the burden onto the arithmetic logic unit. Am I clear? Similarly, if you left a shift twice, is going to result as a 1, and if you divide 2 and divided by 4, decimal portion will be neglected, only integer portion is going to be considered. 5 5. If you left a right shift 3 times and divided by 8, so decimal portion will be neglected because there is a function called as round function that will be result. And 16 and 4 times division, same result, 1 1. How did you get the right shift operation? Same result you take. Now you are taking 20. 20 is 16. 16 is 1 and 8 is 0. 4 is 1. 16 plus 4 is going to become a 20. 2 is 0. 1 is 0. This is the equivalent value for the 20 binary value. If you perform the right shift operation, right shift means what? This is LSB. This is what? LSB. What is the full form of LSB? This is MS.
Least significant bit.
Yeah, correct. So MSB means, what is full form of MSB?
Most significant bit.
Most significant bit, exactly. So whenever you perform the right shift operation, the least significant bit, whatever it is there, is going to be vanished. Is going to be vanished. It's an assumption. We have to perform like that. If we vanish the least significant bit, this particular 0 will be moved to here. Similarly, 0, 1, 0, 1. This is the, after perform the right shift operation, this is the leftover value. If it is a 20, if it is a 20 equivalent binary value, this is going to be a 10 equivalent value after dividing by 2 or right shift one time. 1010 is equivalent to 10 because 8 plus, sorry, yeah, 8 plus 2 is going to become a 10. If you perform right shift one time, the current value of the y is going to become a half. It is equivalent by 2. If we right shift 2 times, again this particular value is going to be vanished. The leftover is 1, 0, 1. It is 101 is going to become a 5. When you perform, when you perform right shift 2 times, when you perform the right shift 3 times, this particular value will be vanished. 10 will be left over. 10 is equivalent to 2. 3 times. When you perform 4 times right shift, again this 0 will be vanished. Only 1 is going to be left over, which is 0, 1 is going to be a 1. Again, if you perform the right shift 4 times, this 1 is also be gone. Only zeros are going to be left over. So this is how the right shift operation is equivalent to the division operation. In what way we are going to apply? In the form of a binary sequence. In the form of a binary sequence, like 8, 4, 2, 1. This is, so 8 will become 16, 16 will become 32, 32 will become 64, 64 will become 128, 128 become 256, 256 become 512, 512 become 1024. Likewise, the left hand side keep on increases the binary weightage value according to the number system called binary number system. Are you clear, everyone, guys? Any doubts?
Yeah, yes.
Yes, yes. Satvika, do you have any questions? Naveen, everybody, please, I'm expecting answer from everybody. Lastly, we have, there is an operator is called as, tilde operator. There is an operator called tilde operator. What is this operator? It's a complement operator. What is a complement? Complement means what? Complement means 0 will become 1, vice versa. 1 will become a 0. Now, if I take V is equal to 10, V is equal to 10. If you perform the ones complement to the V, what exactly you are going to get the output? Let's see. Minus 11 you are going to get as an output. Are you seeing, guys? There is a value called 10. For that, if you perform the complement operation, the resultant value is going to be produced by the computer called as a minus 11. How did you get the value accordingly? Because if you perform theoretical concept like 1 0 is going to be a 1 0 1 0. For that, 1 0 1 0 0 will become 1, 1 will become a 0, 0 will become 1, 1 will become a 0. So according to the ones complement, 101 is equivalent to 5. But here given the result is what? Minus 11, means this output is wrong. So this tilde operator will not perform the ones complement operation. It will be performed, I'll be taking. What is the equivalent value of 10 of binary value? 1 0 1 0. If we perform the complement, it will be performing internally 2's complement. For 2's complement, whatever the LSB bit is there, where I'll be adding 1, binary 1. So that true plus false is going to become 1, 1, 0, 1. 1 0 1 1 is equivalent to, the value is called as a 11, because 8 plus 2 plus 1 is going to become 11. According to electronic level, the most significant bit is going to be a 1. It is a negative bit. If it is a 0, it is a positive bit. Accordingly, here we are going to get minus as an answer. So minus 11. Now, if we give negative value like minus 10, 9 will be the answer. You see, 9. This is how the ones complement operation is going to be performed by the computer with the help of a tilde operator called as a complement operator. Are you clear, everyone?
Sir, please explain again, sir.
See, ఒక వాల్యూ నువ్వు డెసిమల్ వాల్యూ కంప్యూటర్కి ప్రోగ్రామ్కి ఇస్తున్నావు అంటే దాన్ని సిస్టమ్ అర్థం చేసుకునే బైనరీ వాల్యూ వచ్చేసి మైనస్ 11 అంటున్నాను. ఎలా వస్తుంది మైనస్ 11 అంటే, నార్మల్గా నువ్వు ఈ కాంప్లిమెంట్ ఆపరేటర్కి ఈక్వలెంట్గా చూస్తే దాని మీనింగ్ ఏమొస్తుందంటే 10 ఈజ్ అ 10 డెసిమల్ వాల్యూ, 10 యొక్క బైనరీ వాల్యూ వచ్చేసి 1010. ఈ 1010 ఈజ్ అ బైనరీ ఈక్వలెంట్ వాల్యూ ఫర్ ద 10. దీన్ని కాంప్లిమెంట్ చేస్తే ఈక్వలెంట్ వాల్యూ ఏమొస్తుంది? 0 విల్ బికమ్ 1, 1 విల్ బికమ్ అ 0, 0 విల్ బికమ్ 1, 1 విల్ బికమ్ అ 0. దీని యొక్క ఈక్వలెంట్ బైనరీ వాల్యూ ఏంటి? 5. ఇదేమో 10, ఇదేమో 10. 10ని కాంప్లిమెంట్ చేస్తే 5 వచ్చింది. కానీ అవుట్పుట్ ఏమొచ్చింది ఇక్కడ -11 వచ్చింది. అంటే కంప్యూటర్ ఇస్తున్న కాంప్లిమెంట్ ఆపరేషన్ యొక్క అవుట్పుట్కి, అంటే థియరిటికల్గా చెప్తున్న అవుట్పుట్కి, ప్రాక్టికల్గా వస్తున్న అవుట్పుట్కి డిఫరెన్స్ ఉంది. కానీ లోపల ఏం జరుగుతుందంటే 1010ని అంటే బైనరీ ఈక్వలెంట్ వాల్యూ ఆఫ్ 10 దాన్ని లీస్ట్ సిగ్నిఫికెంట్ బిట్ అనే దాని దగ్గర ఒక 1ని యాడ్ చేస్తే 2's కాంప్లిమెంట్ అంటాం దీన్ని మనం. 2's కాంప్లిమెంట్ అంటాం. 2's కాంప్లిమెంట్ చేస్తే ట్రూ ప్లస్ ఫాల్స్ ఈస్ గోయింగ్ టు బికమ్ అ ట్రూ. Obviously these are all zeros, non-weightage values. So 1 plus 0 is going to be a 1, 0 plus 0 is 0, 1 plus 0 is 1. 1 0 1 1 అనేది బైనరీ ఆపరేషన్ ప్రకారం 11 ఈక్వలెంట్ వాల్యూ. ఎందుకంటే 8 ప్లస్ 2 ప్లస్ 1 ఈస్ 11. కానీ ఇక్కడ నెగటివ్ వాల్యూ ఎలా వచ్చిందంటే ఈ మోస్ట్ సిగ్నిఫికెంట్ బిట్ అనే పొజిషన్లో నువ్వు కాంప్లిమెంట్ చేసిన తర్వాత 1 వస్తే అది నెగటివ్ వాల్యూ అంటాం. అదే ప్లేస్లో 0 వచ్చిందనుకో దాన్ని మనం పాజిటివ్ వాల్యూ అంటాం. దాని ప్రకారంగా నీకు వచ్చిన రిజల్ట్ -11. దట్స్ ఆల్. నువ్వు ఎంత పెద్ద వాల్యూ నువ్వు ఇక్కడ వెళ్ళి 1 0 1 0 1 0 1 0 ఇట్లా ఇట్ విల్ బి గివ్ యూ కాంప్లిమెంట్ ఈక్వలెంట్ వాల్యూ. అదే నువ్వు డెసిమల్ వాల్యూ ఇస్తే, ఇప్పుడు ఫర్ ఎగ్జాంపుల్ 9 ఇచ్చాననుకో 8 వస్తుంది ఆన్సర్, చూడండి. అదే నువ్వు పాజిటివ్ వాల్యూ ఇచ్చావు అనుకో 20, v ఈజ్ ఈక్వల్ టు 20 అని ఇస్తే -21 is the answer. This is how. So internally the complement is going to happen over here. So don't think much, because it's a phenomena does by the computer. కంప్యూటర్ అవుట్పుట్ ఎలా వస్తుందో దాని వెనక మ్యాథమెటిక్స్ ఏందో మీరు తెలుసుకోవాలి. అంతేగాని ఎందుకు ఇలానే చేస్తుంది, ఎక్కడ యూజ్ చేస్తారు, ఎందుకు యూజ్ చేస్తారు అంటే నువ్వు హార్డ్వేర్ లెవెల్లో వర్క్ చేసిన రోజు తెలుస్తుంది అసలు కాంప్లిమెంట్ అనే ఆపరేషన్ ఎంత అవసరం. ఎవరైనా ఈసీ వాళ్ళు ఉంటే కాంప్లిమెంట్ అనేది ఎందుకు, దానికి ఆన్సర్ చెప్పండి నాకు, సో దట్ నేను ఇవన్నీ చెప్తాను మీకు నెక్స్ట్ దాని వెనక ఉన్న స్టోరీ. Yeah. So I think today's concept I will be stop the class over here. I think all the operators we have completed. If you look at arithmetic operators, assignment operators, identity operators, logical operators, membership operators, isn't it, relational operators, and bitwise operators. Totally 7 types of operators we have. Till today we have completed 7 types of operators. In tomorrow's class, tomorrow class we have at 9:30. I'll be start at 9:30, and so please, control statement I'm going to start. Any questions? See, please, I request everybody. I have shared the textbook to you. I request everyone, please go through the textbook. Any suggestions you give me, any advices you give me, I am absolutely 100% justification. I'm giving the knowledge about the subject. I think you are not keeping proper efforts. I'm keep on giving assignments or work to you. మీరు అవుట్పుట్ ఇస్తే తీసుకుంటా, లేదంటే నేను సిలబస్ కంప్లీట్ చేసుకుంటూ పోతుంటాను. అల్టిమేట్గా లాస్ట్ డే నాకు బ్లేమ్ చేయకండి. సో బ్లేమ్ ఏమన్నా ఉంటే అది మీ వైపే ఉంటుంది మోస్ట్ ప్రాబబ్లీ. ఈ ఒక 10 మంది ఉంటే అందులో ఒక ముగ్గురు నలుగురు జాబ్లు వస్తాయి. మిగతా వాళ్ళు ప్రశాంతంగా కోర్స్ అయిపోయి ముచ్చట్లు చెప్పుకొని ఏదో చేస్తుంటారు అంతా. సో మీరు ఏ కేటగిరీ అనేది మీరే తెలుసుకోండి. ఇందాకనే ఇంకొక అబ్బాయికి జాబ్ వచ్చింది. ప్రమోద్ అనే అబ్బాయికి ఇందాకనే ఇంకొక ఆఫర్ వచ్చింది. జాబ్లు అందరికి వస్తున్నాయి. అన్ని 11 lakhs 12 lakhs కామన్గా వస్తూ ఉన్నాయి. నువ్వు ఏ కేటగిరీ అనేది, నువ్వు ఏం తెలుసుకోవాలనుకునేది నీ వైపు ఉంది. ఇట్స్ అప్ టు యూ. And I have messaged, I think 1 week back, that those who are going as experienced, If you need a payroll documents, kindly take 1 month or 2 months advance because Form 16s are getting generated little delay. This is my message to be conveyed to you. Indulo almost, Ashwani will be go as an experience. Satvika is a fresher. Naveen going as an experience. Prasanna is going as an experience. And Raghu will be going as an experience. Siva is also going as an experience. I think Likit is the only fresher. I think he might be experienced. I think so. And Harish will be experienced. Many people are experienced in this batch. Meenakshi is experienced. I think so. Please, మీరు ఏ కేటగిరీ తెలుసుకోండి. ఒక క్లాస్ అటెండ్ అవ్వడం ఇంకో క్లాస్ ఆఫ్ బంక్ కొట్టడము ఇట్స్ నాట్ కరెక్ట్. సో ప్లీజ్ యూ థింక్ అబౌట్ ఇట్. సో any suggestions or any messages to me?
No, sir.
Yes, yes. అశ్విని ఉన్నావా నువ్వు? Yes, Naveen, Raghu, Shiva, I think you don't have any questions. I think Prasanna is experienced. I think she will be absolutely fine. She knows everything, most of the things. Right. Thank you so much, guys. So we'll see you tomorrow at 9:30. Thank you.
Yeah, okay, thanks.
Yeah, right.
Okay, sir.
Thank you.
Right.
Okay, sir.
Thank you.